Imagine a ticking time bomb, not one that explodes in seconds, but one that takes millions of years to detonate. What if I told you Earth is home to supervolcanoes so patient, their eruption cycles span geologic eras, shaping continents in the process? These aren't your typical fire and brimstone volcanoes. We're diving into the world of slow supervolcanoes, immense, hidden forces that simmer beneath our feet, moving so gradually they make glaciers look impatient. These tectonic titans are Earth's ultimate long-game players, and their story is one of raw power, patience, and planetary transformation. Ready to uncover the secrets of these silent giants? Let's go. When you picture a volcano, what comes to mind? Probably a cone-shaped mountain spewing lava, ash, and smoke in a fiery spectacle. Hollywood loves that image. Think Mount Vesuvius burying Pompeii or Krakatoa shaking the world with its 1883 eruption. But not all volcanoes are so impatient. Some of Earth's most formidable volcanic systems don't erupt in a single, dramatic blast. Instead, they operate on a timescale so vast it's hard for us to wrap our heads around. These are the slow supervolcanoes, and they're the ultimate masters of disguise. You might think a volcano that hasn't erupted in thousands or even millions of years is dormant or harmless. That's the illusion. Beneath the surface, these giants are anything but inactive. They're quietly amassing magma in colossal underground chambers, building pressure over millennia, and subtly reshaping the Earth's crust in ways that can alter entire continents. Unlike their flashier cousins, slow supervolcanoes don't need to erupt to make an impact. Their influence is felt through the slow, relentless push of tectonic forces, the gradual uplift of land, and the subtle cracking of the Earth's surface. It's a process so gradual it's almost invisible until you zoom out to a geological timescale. So, what exactly is a slow supervolcano? Let's break it down. A supervolcano is defined by its sheer scale, capable of producing eruptions with a volcanic explosivity index (VEI) of 8 or higher, ejecting at least 1,000 cubic kilometers of material. For context, that's enough ash and rock to bury an entire state under meters of debris. Yellowstone, Toba, and Long Valley are classic examples, but not all supervolcanoes follow the same playbook. Slow supervolcanoes are those whose cycles of activity stretch across millions of years, driven by deep-seated geological processes tied to the Earth's mantle and tectonic plates. These systems are powered by massive magma reservoirs, sometimes tens of kilometers wide, lurking deep beneath the crust. Unlike smaller volcanoes that might erupt every few years or decades, slow supervolcanoes take their time. Their magma chambers fill gradually, fed by plumes of molten rock rising from the mantle. The pressure builds so slowly that the surface might only show subtle signs: slight ground uplift, occasional earthquakes, or hydrothermal activity like geysers or hot springs. Yellowstone's Old Faithful is a perfect example, a gentle reminder of the monster simmering below. What sets slow supervolcanoes apart is their connection to tectonic processes that operate over eons. They are often tied to hotspots, regions where mantle plumes punch through the crust, or to rift zones where continents are slowly tearing apart. These settings create a perfect storm for long-term volcanic activity, where magma accumulates without the immediate need for a catastrophic eruption. It's like a pressure cooker on the lowest possible simmer, but don't be fooled that slow burn can still reshape the planet. Let's meet some of these tectonic time bombs. One prime example is the East African Rift, a massive zone where the African continent is slowly splitting apart. This isn't a single volcano, but a system of volcanic activity driven by tectonic forces. Over millions of years, the rift has produced vast lava fields and calderas, with supervolcanic potential simmering beneath places like Ethiopia's Afar region. The magma chambers here are enormous, and while eruptions are rare, the region's volcanic activity has been shaping East Africa for tens of millions of years, creating landscapes like the Ethiopian highlands. Another heavyweight is the Siberian Traps, a relic of one of Earth's most devastating volcanic episodes. About 250 million years ago, This slow supervolcano system unleashed a flood of basalt lava over millions of square kilometers, contributing to the Permian Triassic extinction event, the worst mass extinction in Earth's history. The Siberian Traps didn't erupt in one cataclysmic blast, but oozed lava for nearly a million years. That's the hallmark of a slow supervolcano, not a single explosion, but a prolonged, relentless outpouring of material that reshapes the planet's surface, climate, and ecosystems. Closer to home, consider the Long Valley caldera in California. While it's capable of explosive eruptions, its history spans millions of years, with periods of intense activity separated by long stretches of quiet. The caldera's magma chamber is still active, causing measurable ground uplift and seismic activity. It is a reminder that these systems don't need to erupt to be awake. They are constantly at work, shaping the landscape in subtle but profound ways. Slow supervolcanoes don't exist in isolation. They are deeply tied to the Earth's tectonic dance. The planet's crust is a patchwork of plates, constantly shifting, colliding, and pulling apart. Supervolcanoes often form where these plates interact in unique ways, like at hotspots or rift zones. Take Yellowstone, sitting atop a mantle hotspot that's been active for at least 17 million years. As the North American plate drifts over this hotspot, it leaves a trail of volcanic activity stretching across the western United States. The Snake River Plain, a vast volcanic region, is essentially Yellowstone's geological footprint, carved out over millions of years. Rift zones, like the East African Rift, are another hotspot for slow supervolcanic activity. Here, the crust is thinning as tectonic plates pull apart, allowing magma to rise closer to the surface. This process is agonizingly slow. Continental rifting can take tens of millions of years, but it creates conditions for massive magma chambers to form. Over time, these chambers can produce supervolcanic eruptions or, more commonly, prolonged periods of lava flows and crustal deformation. What is fascinating is how these tectonic processes link slow supervolcanoes to the broader story of Earth's evolution. The movement of plates doesn't just trigger volcanic activity. It shapes continents, builds mountain ranges, and even influences climate. For example, the Siberian Traps' massive lava flows released enormous amounts of carbon dioxide, triggering global warming that devastated life 250 million years ago. Slow supervolcanoes, in their patient way, are architects of planetary change. You might wonder, if these supervolcanoes are so slow, why should we care? The answer lies in their outsized impact. Even without erupting, slow supervolcanoes reshape the Earth in profound ways. Their magma chambers cause the ground to rise and fall, creating vast calderas or uplifting entire regions. The East African Rift, for instance, has sculpted some of the most dramatic landscapes on Earth, from towering volcanoes like Kilimanjaro to the vast plains of the Serengeti. Their influence extends beyond geology. Slow supervolcanoes can affect climate, ecosystems, and even human history. The Deccan Traps in India, another slow supervolcanic system, erupted around 66 million years ago, releasing gases that may have contributed to the climate changes linked to the extinction of the dinosaurs. On a smaller scale, hydrothermal systems tied to supervolcanoes like Yellowstone's geysers create unique ecosystems that support specialized microbes and wildlife. For humans, these systems are both a blessing and a potential threat. Geothermal energy from supervolcanic regions powers communities in places like Iceland and New Zealand. But the flip side is the risk of rare but catastrophic eruptions. A supervolcanic eruption today could blanket entire continents in ash, disrupt global climate, and cripple agriculture. The odds are low, but the stakes are astronomical. So, how do we study these slow giants? Geologists use a range of tools to peer beneath the surface. Seismic imaging, for instance, maps magma chambers by tracking how earthquake waves travel through the Earth. GPS and satellite data measure tiny changes in ground elevation, revealing the inflation or deflation of magma reservoirs. Geochemical analysis of rocks and gases helps scientists understand the composition and behavior of these systems. Places like Yellowstone are monitored around the clock. Scientists track earthquakes, ground deformation, and hydrothermal activity to gauge the system's pulse. While a catastrophic eruption is unlikely in our lifetimes, these measurements help us understand the long-term behavior of slow supervolcanoes. They're like doctors checking the vitals of a sleeping giant, looking for signs of restlessness. Slow supervolcanoes remind us of our place in the grand sweep of Earth's history. We're used to thinking in terms of years or decades, but these systems operate on a timescale that dwarfs human existence. They're a humbling reminder that the Earth is a dynamic, living planet, constantly reshaping itself in ways we're only beginning to understand. Yet, there's something inspiring about their patience. These tectonic time bombs don't rush. They build, they wait, and when they act, they change the world. They've carved mountains, sculpted continents, and even reset the course of life on Earth. As we study them, we're not just learning about volcanoes, we're uncovering the story of our planet's past and future. Slow supervolcanoes are Earth's ultimate long-game players. They don't need to erupt to make their presence felt. Their influence is woven into the fabric of the planet's crust, shaping landscapes, climates, and ecosystems over millions of years. From the Siberian Traps to the East African Rift, these tectonic time bombs are a testament to the immense power of geological patience. As we stand on the surface of this ever-changing planet, it's worth pausing to appreciate the forces at work beneath our feet. They're slow, they're subtle, but they're unstoppable. The next time you hear about a supervolcano, don't just picture an explosion, think of a quiet, relentless force ticking away on a geological clock, ready to reshape the Earth in its own time.